All right, everybody, welcome back to the Anatomy video lecture series. As you can see behind me, today we're going to talk about blood groups and blood typing. And we'll explain type A, B, and O blood groups and why some of those bloods can only be given to people of certain blood types. So let's go ahead and have a look. All right, everybody, welcome to video lesson 4 on the cardiovascular system. And today we're going to talk about our blood and blood types, also known as blood groups. Red blood cells have, well, as a matter of fact, all cells in your body have proteins on their surface which act as antigens or surface markers. They identify your cells. They identify them as you. Even with the same species, the antigens of one individual are not necessarily compatible with those of another. So if you've ever seen any of the signs that say, a kidney donor needed, those people have probably tested their immediate family, and they don't have a donor that's readily available to them. So they need to search a wider range to try to find someone that has the appropriate antigen markers that the recipient's body will accept within reason. And then even after the transplant has taken place, that person will probably still be on immunosuppressors so that their immune system doesn't attack that new organ. If not, then you have tissue rejection, and the body's immune system actually will destroy, for lack of a better term, the new organ, even though the individual needs that organ to survive. And this is also true with blood. This is why only certain people can receive blood from certain people, and other people, depending on their blood type, can only give blood to people of a similar blood type. And we'll talk about all of those different parameters here in today's lecture. For this reason, before donor blood cells can be transfused to another person, the major surface antigens must be determined. So the individual is going to have either A antigens or B antigens, or both, or have neither, and that will determine their blood type. The most significant markers currently known to exist on the red blood cells are the A and B antigens. In transfusion medicine, the presence or absence of A and B red blood cell antigens forms the basis of the ABO blood group system. So if you are type A, then your red blood cells will have A antigen markers. If you are type B, then your red blood cells will have type B antigen markers. If you are type AB, you'll have both A and B antigen markers. And if you're type O, you have none of those A or B antigen markers. Another major red blood cell antigen is the Rh antigen, which 85% of the population will be Rh positive, or they will have the Rh antigen, and comprises another important blood grouping. And we'll talk about that here in a little bit. But when you ask people about their blood type, they'll say, I'm either A positive or B positive. I personally am A positive, so that means my red blood cells have the A antigen, and I am also carrying the Rh antigen, so I am Rh positive. And positive means you have the antigen, negative means that you don't have the antigen. And since 85% of the population is Rh positive. Most of us are going to be either A positive or B positive, or any of the other combinations of blood typing that's out there, whether it's AB or O. We're all mostly going to be Rh positive. And then here in a little bit, when we get through the ABO component, we'll talk about the immune response in the absence of the Rh antigen. Individuals with A antigens on their red cells have the anti-B antibodies in their serum of plasma. That simply means that if they are, as I am, if I have the A antigen, then I carry the antibody that will attack any red blood cell that has the B antigen. So if I'm given a transfusion of blood from someone that is either B or AB, then those red blood cells are going to have the B antigen and my immune system will attack them. The opposite is true for someone with the B antigen. They have the anti-A. So if they receive a blood transfusion from someone with the A antigen, their immune system will attack those blood cells. So they cannot receive anyone with the A antigen, which would be type A. And of course, the type B, AB blood group also has the A antibody. And so they can't receive blood from that individual either. Now, if you are type AB, your blood has both A and B antigens. So you have 0 antibodies fighting the AB blood group or antigen, because then your immune system would attack your own blood, and your immune system isn't going to do that. If you are type O, you have the antibodies for both A and B, so you can't receive blood from anyone that's type A, type B, or type AB, because those individuals all have the antigens that the immune system will attack if you are type O. By knowing the status of the A antigen, B antigen, and Rh antigen, most of the major blood incompatibility issues can be avoided. Type AB individuals are universal recipients because they have no antibodies against the A, B antigen group. They can receive blood from anyone because they have no antibodies against A or B in their blood. And then, of course, type O, since it has no antigens, can be given to anyone. So type AB is the universal recipient. Type O is the universal donor. So if you ever, if you watch your medical shows and they bring in someone that's been injured and they need a blood transfusion, they always ask for O negative. The reason is they have no idea what this person's blood type is. So since O is the universal donor, they can give O to anybody, whether they're A, B, or type AB. Even if they're O, they'll still be safe. And then you give them negative, because if they're positive, then the blood won't attack it because it has no Rh antigen. And if they're negative, it obviously won't attack it because they don't have the Rh antibody. So the safest blood to give someone in an unknown scenario is type O negative, because if the individual is positive or is negative and you give them positive blood, then that can trigger immune response. And we'll talk about that here in just a minute. Type O individuals are the universal donors, as I mentioned on the previous slide, because their red blood cells have no antigens on the cell surface that can potentially react with the recipient's serum. So how do you figure out blood type? It's pretty simple. For the ABO status, you simply take a drop of blood and you add something that's called agglutination, with an anti-seral indicates the presence of that antigen on the RBC. So if you have a drop of blood and you treat it with the anti-A, so that would be the antibody carried by someone with B blood, and it coagulates, then and forms a clot like that, then that means there's a good possibility you're dealing with type A blood. If you give it the anti-A or the anti-B and nothing happens, then that means you have the antibody that fights B. You have the antibody that if it destroys A, then that means you are type A. If you have a drop of blood and the anti-A doesn't affect it, and the anti-B will cause it to clot, then you have type B blood. If you have a drop of blood and the antibodies affect it all, you have type AB. And then if you have a drop of blood and these serums do nothing to the blood, then you have type O. Normally, blood plasma does not contain anti-Rh antibodies. Individuals with red blood cells having the Rh antigen are said to be Rh positive, while those who lack the Rh antigen are Rh negative. Rh incompatibility can cause problems with any blood transfusion, so it is screened just as carefully as the ABO antigen. Perhaps the biggest problem with Rh incompatibility involves mother and child during pregnancy. So here's what happens. If blood from an Rh positive fetus synthesizes an Rh mother during birth, so first of all, remember, 85% of the people walking around are Rh positive. So the mother has to be Rh negative, which is only 15% of the population. So this doesn't really happen a lot, but the risk is out there. And anti-Rh antibodies will form in the blood of that woman. So when the blood mixes during the pregnancy or during the birth, the Rh negative woman develops antibodies against the Rh positive blood, so that if she is exposed to Rh positive blood a second time, then there will be an immune response. During her next pregnancy, those antibodies can cross the placenta to affect the next baby. And in essence, the mom's blood can be affecting the baby's blood. This is called hemolytic disease of the newborn, or HDN, results when the Rh positive fetus develops in the womb of an Rh negative woman. The way I understand it is that if they notice on the first pregnancy that a woman has, if she's Rh negative and she gives birth to an Rh positive baby, then during the next pregnancy, there's medication that the woman can be on to stop her from attacking the baby's blood. I may be incorrect on that, so don't quote me, but I'm pretty sure that that's how that is handled nowadays. So here are the blood types in the population, our population, just to give you an idea. The most common is type O positive at 38.4% of the population. Coming in second is A positive at 32.3% of the population. If you add in the O negative individuals at 7.7% of the population, that means just type O is almost half of the people walking around are type O at 46.1%. Type A, if you add in both positive and negative, you're looking at 38.8%. Type B, not as common, coming in at just under 10% of the population are going to be B positive. Only 1.7% of the population are B negative. It's coming in at just over 11% of the population are just type B. And the rarest of all is type AB at only 3.2% A positive, and less than 1% of the population are AB negative. And so if you're type AB, It's only about 4% of the population are type AB. So chances are, those of you listening to this video, you're one of these right here. You're either type O or type A. And most of us are going to be right here or right there, A positive or O positive. All right. I believe that is going to be all for video lecture 4. All right. That should do it. So I don't know if you know what blood type you are, but hopefully that will help you understand why, if you're type A, you can only receive blood from someone that's type A or type O, or vice versa for type B, and so on and so forth. So as always, if you have any questions, just shoot me an email and I will answer it to the best of my abilities. If not, I thank you for watching. And because I'm a YouTuber now, don't forget, click like and subscribe. We'll talk to you later.